Hey, welcome back everybody. We're on lesson number 5, graphs of sine and cosine. Right away, I'm going to have you pause the video and copy these two graphs down. So do that right now. Alright, so you'll notice hopefully a couple of real quick similarities. Some things like our amplitude on both sine and cosine is 1, and we have a period of 2 pi for both of these. And looking at the general gist of these both, they're cyclical, right? They repeat over and over and over. Okay, I just mentioned a couple of words like amplitude and period, so I'm going to have you copy these definitions as well, and you can see these definitions right here. We'll talk about them after you copy this. Okay, so amplitude is just half the distance between the minimum and maximum range, right? So the highest of the high, lowest of the low, that's your min-max, and we're talking about the halfway between them. Okay, so that's what your amplitude is, and a lot of people think of it as height of the wave. Then you have your period, which is the distance it takes to complete one cycle. So this thing repeats over and over and over. So when we look at one starting point and ending point of a cycle, we would call that a period. And we can see that the period can change using that formula 2 pi over b. Now amplitude and period will be talked about a little bit more in detail when we start messing around with these graphs, because as you can see right now these graphs are very general, just a height of 1, a period of 2 pi. So what happens when we start moving these things around and making them bigger or wider? Okay, so that's what's going to happen. So here's the general setup for the functions, right? You've got f of x equals plus or minus a times sine or cosine of b times x minus c plus d. Okay, so here's what's going on. This is just like every function that we've worked with so far. You have a negative on the outside that will flip the function. Okay, that's the usual, right? Nothing different happens with that. And you have this multiplier. Now, the multiplier in the past has made things taller or wider. So it should make sense that a multiplier here would make our amplitude taller or wider. So we're going to see that that's what happens. Okay, then we have the actual function. Right now we're working with sine and cosine. And depending on which one we're working with, we have specific starting points that we got to keep in mind. Okay, and then you have this b value. This is where our function will get either wider or stretched out or compressed, and it will look really spring-like. And you have your shifts. Our c value, if it's going to be a horizontal shift, right, opposite sign for the direction. And then finally, your d value outside is a vertical shift. So we're just going to be putting together basically what we've been doing in the past, all with the sine function. And we want to just keep in a few points and some things in mind. So here's our first example. We have negative 2 sine of x minus 2 pi, and then they gave us a range. So we want to see what this thing looks like between negative pi and 3 pi. So I've already went and set up my coordinate plane for this problem. And what we want to do is keep in mind some really basic ideas for sine, right? Sine started at 0, 0, and then it went up and then down, right? That was the original look of sine. Well, we're not starting in the same place, right? This has moved, a horizontal shift, and we're not going in the same direction. We're going opposite. We're going down, right? So let's deal with this first. This tells us to move half a pi in the opposite, so positive direction. So normally I'm starting here at 0, 0. I'd want to move out to not all the way to pi, but halfway. Right, here's half pi. So that is where I'm going to start. Right, there's no vertical shift at all happening. It's just moving over. Then, because I'm usually going up, I know I'm going to be heading down. But I want to be moving twice as far as usual. So if my amplitude that we talked about for sine is just a height of 1, I need to be going a height of 2. But here I'm going in the opposite direction. So I need to be down here at pi. Now remember, we never made this any wider than before, so we're still working with these half marks. That's where all the action really happens with these problems. Okay, so now we're going to go up here to positive 2 and then back down. And on the other side, I know that it's cyclical, right? So I should be going in reverse this way. So I need to go up to 2, back down to 0, and then down to negative 2. Okay, so that's what that function is going to end up looking like. We're going to draw it in. And here's everything that happened. The negative forced us to go down. This negative half pi, we go opposite sign, so we end up going over half a pi. And then this 2 affected our amplitude, right? Normally our function is only this high up, 1 unit, but we needed to double it, so we're now 2 units in height. Okay, makes sense? I hope so. We've got another one to try, right? 1/2 cosine of x minus 1. Again, we're working in this window of negative pi to 3 pi. So let's deal with any kind of shifts first. Cosine, we know, starts at 1. But we have a vertical shift here of down 1. So if I usually start at 1 and I gotta go down 1, I'm gonna be down here at 0. But what's really more important, if you ask me, is the that average height. That's what's really changing here, right? Normally, your function for cosine is going like this. It's going from 1 to 0, then down to negative 1, then up to 0, right? So that's what's usually happening with this. But what we want to change, really, because I already messed this one up, right? It's the average height. So we want to move that 0 point down 1. So we got to go down here to negative 1. And I'm going to actually highlight that in green for us so we can see it better. Okay. So we're moving down here with green, and that's where this function is going to start to loop around, right? Because I neglected to mention that we have this 1/2 that we have to contend with, right? So instead of it being that point up here that moved down 1, it was just our starting or our midpoint that moved down 1, right? And our amplitude here, they want us to be 1/2. So we don't even want to go up 1 like we normally would do for cosine. We only want to go up 1/2. So that problem is now fixed, right? And generally speaking, cosine, it goes from 1 and it drops down to the middle, right, at half pi. So we've got to go to half pi, which is right here. And now we're at our midline. And then it keeps on going down, right? So we got to go down. But now we're only going halfway, right? So it's not going to be a full distance. It's only going to be halfway. And it stops at pi. And then it comes back up at half pi mark. And then we're up only half the distance, right? So this is what this function really should look like. Don't tell anybody that I put that one there, okay? Here we go. Right, so what did we do? We were given this downward shift, which we took care of absolutely first, because if we didn't, we made an error, right? So we had to move down our average point, and we drew it in, okay? Then we thought about our amplitude. We knew that cosine normally starts at 1, but we only wanted to be half the distance, so we dealt with that right away. Okay, and then we just kept on cosine's function. There were no horizontal shifts, so this worked out in our favor. So here's one for you to try. pause the video, try it out, make an error or two if you have to, and we'll fix them in the end, just like we did last time. Alright, let's see how you did with this. You were working with cosine, and hopefully you noticed that you had a vertical shift right away, and you put that down and didn't make an error that anyone on the internet can see. I'm going to stop talking about that now. Anyway, here's our average line. Okay, and we have something else happening to it, right? We have direction change, right? Negative, it's going to flip. And our starting point is moving backwards half a pi. So normally, cosine's 1 above our average line, but we got to move it back half a pi. So I got to shift back here. And that seems to be all the things that we needed to worry about for cosine, right? It's just shifting back, and it's flipped. It's flipped. So no, it's not starting up here at 1, right? It's starting down here, negative, we'll say negative amplitude. So it should be starting down here at 0. And then where does it go from here? It's going to have to go up, right? It's not getting any wider. We haven't messed with the period at all, so it's always going to be working with the half marks, right? So here's a half pi mark, half pi mark. Oh, but we messed up somewhere, didn't we? Oh, we never dealt with this. Half pi. Oh, we did. We did the half pi. Okay, so we're good. I don't need to be so paranoid, I guess. Right, here we go. That seems to be the graph that we're looking for. Hopefully you got that, and we can move on to the next one. Alright, this time they give us 1/2 amplitude of sine times 2x. Whoa. Well, that's something that's messing with the period. And if we want to see exactly what's happening to this, we're going to take 2 pi and divide it by whatever our b value, our amplitude is. So we divide. That's telling us that our period now is pi. So if you think about it, sine was going all the way to 2 pi before it repeated. That means now it's getting cut in half. It's doing all of this and ending at pi. So what really happened? All of our halfway marks that we've been working with in the past problems, right? You can't see that because that's off the screen, right? We've been working with those halfway marks this whole time, right? Half pi, half pi, half pi. We just cut that in half. So now we're working with quarter pi marks, right? So we've got to work with these quarter pi marks now instead of the half. But we're lucky because our amplitude is also being cut in half. No vertical shifts, no horizontal shifts. So I'm not going to draw this in, but we have our average line still here at 0. Sine always starts at 0. We're only going halfway up. So instead of going up to 1, we're only going to go up to the half. And instead of going to half pi, this told us to go to quarter pi. So every quarter pi increment, we're going to make our marks, right? So here we go. Quarter pi, right? This is half distance. Quarter pi, quarter pi. And there's our graph. On the other side, right, it's got to go down to begin with, so that it repeats the pattern. And it's still every quarter pi value. So here's what our function looks like. These are the ones that are really scrunched up. Okay, so here you go. You have one to try out. Pause the video and resume when you're ready to check it. Alright, so first thing that we got to deal with is that vertical shift, right? We're at -1. So we're going to put in our average line at -1. Okay. Then we have no horizontal shift, no amplitude change or direction change, right? It's still positive, so it's going to start at positive 1 above, right? So it's going to start here. What we've got to worry about now is the period, right? We had 1/2 for our b value. So if we divide 2 pi by 1/2, that's like taking 2 pi and multiplying by 2 over 1, which is 4 pi. So our graph isn't even going to be big enough for us to see within the window that they're looking for. So you might have even had to have drawn 4 pi if you wanted to see the whole thing. Okay. Actually, that's not true because we'll see some of it over here. But let's graph it out. We're still starting 1 above. So we should be here at 0. But now instead of us working with half pi increments like we've been doing in the past, we get to work with full pi, right? Twice the distance. So I'm going to go out to a full pi, and then I go to my average line. And then I'm going to go out another full pi, and I have to go down 1 unit, which is down here at -2. Then I'm going to go another full pi, and I'm back at 0. And it's going to continue on. This direction, I've got to go back down, but I'm doubling the distance, right? So I'm here at -pi. I'll just have to connect. So we did actually get to see the full thing. Right, and continue off. There you go. I think that's it for that lesson. Hopefully this stuff didn't make too much confusion for you with my little bits of errors here and there, but overall these aren't that bad if you take your time and look at it and go through step by step, right? Deal with any vertical shifts first. That'll take care of your average line, and then you can start looking at your amplitude, and it will help you judge how much height to give it. Then the period. Alright, do I need to work with half pi units? Do I want to work with quarter pi units? Full pi units? Hey, who knows? You might be working with 2 pi units. Just find the period, and that will help you. Okay, so I'll see you next time when we work with the other trig graphs. Till then,